Okay, so today we are doing quadratics, topic 2. This is applications of quadratic functions. So we learned how to solve quadratics by factoring, and we learned how to solve quadratics by the quadratic formula. So now we're doing those applications. So I'm going to draw a picture. So I want you to draw this on your notes. So we're going to draw a little guy. He's going to have a ball in his hand. He's going to throw that ball. Then it's going to go and hit the ground. Okay. So this is this motion of the ball going up and falling down. We can describe this as an equation, a quadratic equation. Because if you notice, this makes an upside down U shape. So U shapes, right, are quadratics. This is actually a negative quadratic because it's upside down. So my A values on these would be negative. And we have two equations that have negative A values because, like I said, the motion of throwing a ball in the air and then it falling to the ground is going to be a negative quadratic equation. So we have two because one is for meters and one is for feet. Okay? So some other things about these equations. You have two types of input values. So two things that you're going to have to get out of a word problem to be able to use this equation. Those two things are your initial upward velocity, which we say is VO, and then our initial height, which we put as HO. These are going to be your input values that you're going to need to put into the equation. Okay, so let's say we're reading an equation. We find out that we're measuring in meters. I'm going to use this formula. So I would start out writing H equals -5 times the time plus some, no, oh, sorry, we got to put squared, sorry, times squared plus some number, that's VO, times your T value, plus another number, which is going to be your H value. Okay, so whatever number they give me for the initial velocity is what I'm going to put here. Whatever number they give me for the initial height is what I would put in here. So whenever I'm doing a word problem and I know that it's in meters, I'm going to go ahead and just write this out. And then when I'm reading the word problem, I'll find the initial height, I'll put it in here. I'll find the initial velocity, I'll put it in here. Initial height, I will put it here. Okay, so now in your calculator, you're not going to be using H and T. You're going to be using X and Y. So I'm going to translate this into X and Y. So instead of height, I'm going to put Y. Instead of T, I'm going to put X. Okay? So like I said, in the calculator, you're just going to change it to X and Y. Okay, so what is it that we're exactly solving for in these equations? We're solving for the height. So at any given point in time in this course that the ball is taking, we can find out what the height is for that ball. So let's say 1 second passes, the ball is going to be at this height. Let's say 3 seconds pass, now the ball's at this height. That's what this equation is going to give us, the height at any given point in time. Okay. So let's go ahead and do the same thing that we did here for meters. Let's do it for the formulas for feet. So let's say I have a word problem, we're dealing with feet. I'm going to write this out. I'm going to write my height equation as H equals -16 T squared plus some velocity T plus some initial height. And then if I want to translate that into X and Y, I would make this Y equals -16 X squared plus some initial velocity X plus some initial height. Okay, so let's go ahead and find out if we can do this in a word problem. So let's look at the next part of this. says Felix is playing in a soccer game. Okay, so he's playing in a soccer game. So let me just go ahead and draw a little person. He's playing a soccer game. He kicks a soccer ball. So he's going to kick this soccer ball. It's going to go up in the air, and it's going to come down with an initial upward velocity. Okay, so these are key words here. I know my upward velocity is something that I need, so I'm going to be listening when I hear that. So my initial upward velocity is 25 meters. So my initial velocity is 25 meters. Okay, I'm going to keep going. Per second. With an initial height, okay, I know I need that too, so I'm going to be listening here. My initial height is at ground level. Okay, so I had already kind of gotten ahead of myself, but the ball is at ground level, which makes sense because you're playing soccer. But ground level would mean that this initial height is going to be 0. So anytime they say ground level, you're going to be putting 0 for that. So I got my 2 input values. So let's go ahead and see what equation are we going to be using to find the height here. It says meters. So I know I'm going to be using this formula. So I'm going to write this out. H equals negative 5t squared plus my velocity times t plus my initial height. Okay, so this was my initial velocity, this is my initial height. Okay, so we already got those values. 25 is my initial velocity, so I'm going to put that in. 0 is my initial height, so I'm going to put that in as well. All right, great. I have my equation. So let me just translate that into y and x. So this will be y equals negative 5x squared plus 25t. Don't forget that t. Oh, sorry, not t, sorry. Sorry, not t. X. So we're going to put x. Plus 0. Okay. So we got our equation. Now let's see what they're asking for here. It says, calculate the height of the soccer ball after 2 seconds and after 3 seconds. Okay, so you can do this in one of 2 ways. You can, so let's remember, t equals x. So when they're saying time or giving you time, that's your x value, and vice versa. So we want to know what the height is. So what is the height when your time is, or your x is, 2 seconds? And what is your height when your time is 3 seconds? Remember, t is x, y, sorry, h is y. So I could do this one of 2 ways. I could just put this number into the equation and figure out what y is. This would be good if you don't have a calculator at home. Like if you don't have one of these fancy calculators at home, you could just put this in straight into the calculator, like we could plug in the value into the calculator. So I could put in, instead of x, I'll be putting in 2. So if I put 2 in for x, I'm going to put in negative 5 parentheses, I'm going to put in 2 squared plus 25x, so plus 25 times my x value, which is going to be 2. Okay, so see, I'm just plugging in the 2 for the x, plus 0. So I'll get a number out. That's 30. Okay, so my height at that point is 30. Let me do the same thing, but this time I'm going to put in 3 for x. So I'll put in, again, I'll put in negative 5. I'm going to put parentheses times 3 this time, squared, plus 25x. My x is 3 here, so I'm going to put in 3. Plus 0. Okay, so I will put that in. I'll hit enter. That gives me 30 again. You might ask yourself, is there something wrong? Why do we have 32 2 times. Okay, well, that's because at some point here, after, let's say, 2 seconds, your height is 30. Well, that's going up. You're going up and you're hitting 30 feet. And then at some point you peak, and then you start going down again. And when it comes back down, it's going to hit 30 feet again, and then it'll hit the ground. So that's why there's 2 30s. One that's going up, you hit 30, you peak, you come back down, you hit 30 again, and then you'll hit the ground. Okay, so that's why there are 2 values that have 30 for their height. 2 times that have 30 for their height. Okay, there's another way that you could do this. You could also get the graph on this calculator. Okay. But like, I know that a lot of you don't have that at home, so I will probably do this in another video, the next video that I'm going to do after this. But if you don't have a fancy calculator at home, just plug in your x values into the equation, and then whatever you get is going to be your height or your y value. Okay, just like we did. All right, I hope you guys have a good day. That's all that we did today. I'll continue this tomorrow. All right, thanks.